a structural engineer really is an engineer that um, has to understand materials, material behavior, what's strong, what's weak, what's stretchy, what's stiff, um, in order to use them effectively in constructing buildings, roads, bridges, tunnels, everything kind of built environment. One of the things that attracted me to want to become a structural engineer was they were just finishing the building of and then opening the Sydney Opera House about the time I was doing my A-levels and thinking of what to do next. I had and the Sydney Opera House I found really, just inspiring, incredible. The idea that you could do that with materials that normally didn't do that sort of thing. The beautiful shells overlooking the harbour, and I think that was an important aspect. And it's actually what led me on to try and get a pre-university job with O'Varra. And they said, Ted Happold happened to tell me he needed an extra student to help with this project they're doing. And it was a project in Mannheim in Germany to build a very unusual building. I mean, it looked like a very organic shape, a series of kind of interconnected domes, all going to be made out of timber, and it had to be built in a hurry. I joined that team, and it was my job predominantly. They'd already built the model, so my job was to load test it and use the model to predict when the real project would buckle. The major catastrophe of these kind of shapely dome structures is that they might buckle and collapse inwards. So I did a lot of model testing. Halfway through my time at Cambridge, and it's only a 3-year course then, in those days, I got a call saying they'd left Arup and set up a new practice down in Bath, and would I like a holiday job? Of course, that was starting with a brand new firm, doing, taking more responsibility, and then ultimately being chairman before I finally retired. The first time I really felt that I'd been let loose, the turning point in my career was, like a lot of people, when I was sent to site. And of course, the excitement of being right in the middle of Hong Kong, this site for the cultural centres overlooking the harbour, across to the island where all the tall buildings were. This was the most incredible, unusual structure, which was three cable nets, which had to be put up high up in the air, which were going to go over a concert hall, over a theatre, and then over a big foyer. That was lots of lovely, tricky problems to deal with. When I start working on a project and I'm talking to architects and clients, I kind of instinctively trying to see how could we make it more efficient and effective by using shape. The competition entry that Foster and Partners were putting in for the British Museum, where they were going to rediscover the courtyard, and part of that was to create a roof over the courtyard. And the only way we could, really make it as light as they wanted it was in a very curvy shell. But it looked so beautiful when we started to model it that it was a real winner. So the British Museum roof, it's called the Queen Elizabeth II courtyard now, was probably quite a landmark project for me. Back in the late 90s, it was a millennium project, so it had to open year 2000. I'd always had a sort of recognition that good structural engineering was about using the least material, and increasingly maybe to try and use natural materials because they seemed less environmentally harmful. So using timber and so on where you could. And I hadn't fully appreciated how big the impact of the materials that we use, i.e. the work of the structural engineer, is as well. And it's what we call embodied energy, the embodied carbon dioxide emissions in the materials that we use when we specify steel or concrete. And in a way, that's what led me to get so excited when I first heard about Seratech and what a couple of students, Sam and Barney at Imperial College, who I'd got to know, felt they were able to do to greatly reduce the impact that cement making was going to have. I wanted to do all I could to help make sure that what sounded like such a good idea would come to fruition. It wouldn't just be a pipe dream. But to get it to the scale we need to first demonstrate to the industries that want to use it just how easy it is to use, how easy it is to make, how simple the technologies are.